All right, so let's get started here. We're going to do a video on inverse functions and their derivatives. So first, I want to do a little bit of discovery learning there for you. And so here's a function, x cubed, and its derivative is the cubed root of x. Now, how do they determine that? Well, an inverse is when you switch your x and y. So that's what an inverse is. So for this, all they did was they switched their x and y, and then they solved for their y. So that's why they're going to get y equals x to the 1/3, which is the same thing as the cubed root of x. So let's go through this, and let's answer these questions. So f of 2, so we plug in a 2, you're going to get 8. F prime is going to be 3x squared. And f prime of 2, so plug in a 2 into here, and we're going to get, looks like a 12. Now let's go do the same thing on the other side. So we're already given the inverse, that's great. So plug in an 8, and we're going to get a 2. The derivative of this is going to be, well, it's the same thing as x to the 1/3, right? So I'm going to get 1/3 x to the negative 2/3. And then 8, you plug in an 8, you're going to get, well, it's nice to know that this is really 1/3 cubed root of x squared. Kind of hard to see there, but that's what it is. So if I plug in an 8, I'm going to get 2 squared is 4 times 3 is 12. So it's 1/12. Okay? Looking at the screen, I'm thinking orange is not a good color. No more orange. We are retiring you. Okay. So what do you notice about our answers for C and F? They are reciprocals. Okay. So what's important about that is inverse functions. This is our lovely little formula we have down here. Is if you take the derivative of an inverse, it's going to be 1 over the f prime of the inverse, which is exactly what happened here. Okay. So now let's do a little bit more of discovery learning or finding the derivative of an inverse. This is a bit more of a complex one. So it says to determine if f of x is 1-to-1. Now, 1-to-1 means that f of x is a function, and the inverse, f to the negative 1, is a function. Okay? So that's what 1-to-1 means. It also means it passes the vertical line test and the horizontal line test. So that means it's 1-to-1. So to determine if something is 1-to-1, we don't really have enough skills really to do a problem like this. We do it to do a problem like this, but like these types of problems. So this is a very specific, picked out problem for us to do. So what I'm going to do is to see if something's 1-to-1. If something's always increasing, no matter if it wiggles as it increases, that's 1-to-1. Or if something that's always decreasing, then that's 1-to-1. When it starts to increase, then decrease, that's when you have some problems. So if this is strictly increasing or strictly decreasing, then I'm good to go. That's the most simplistic way to figure out if something is 1-to-1. So to find out if it's increasing or decreasing, you're going to take the derivative. So the derivative is 5x to the 4th plus 1. Okay? So this function, is it always increasing? Well, is the derivative always positive? Is the derivative always negative? I'm telling you right now that this is always positive. How do you know that, Coach Meidenbauer? Well, let me tell you. So since this is being a 4th power, that's always going to be positive. So no matter if we plug in a negative value, it's always going to spit out a positive value. And then since we're adding more numbers, it's going to make a positive number even more positive. So this is always positive. So since it's always increasing, it is 1-to-1. So let's go ahead and find the derivative of the inverse. So if I'm giving you this right here, this is the same thing as y equals x to the 5th plus x plus 1. Now, to find the inverse, you need to switch your x's and y's. So you're going to get this right here. X equals y to the fifth plus y plus 1. And then we're going to take the derivative of this because this is the inverse. Okay? So we're going to go ahead and take the derivative of this inverse. And we will be good to go from there. So the derivative of x is 1 equals derivative of y to the fifth is 5y to the fourth. Tag it dy dx because we're taking a derivative with respect to x plus derivative of y, it's dy dx. Derivative of 1 is 0, so I just leave it. So on the right-hand side, I'm going to take out a dy over dx, and we're left with 5y to the fourth plus 1. So to get dy dx by itself, I'm going to get 1 over 5y to the fourth plus 1 equals dy over dx. And then, well, this is it in terms of y. So this is the this is the derivative of the inverse. Okay. You can also plug y back in from here to make this 1 over 5 x to the fifth plus x plus 1 all to the fourth plus 1. And that's going to give you the derivative of the inverse. So there are easier ways. Usually it's easier if we're given more information. So let's go ahead and do that right now. So this first question up top here, we're going to be given all of the pieces for our problem. So we're going to be given f of 3 is 5. F prime of 3 is 7/2, and we're going to find inverse f prime of 5. Try to make this not crooked the entire time. Okay, so what you're going to do for this is, well, first off, what's the formula? And if you don't know or don't remember, it's right up here. So to find the derivative of this, it's going to be 1 over f prime of the inverse of 5. Okay. Now, this first information we were given, this is what's really going to help us out. Since f of 3 is 5, the inverse of 5 is 3. Because remember, we just switch our x's and y's. So this is going to equal 1 over f prime of 3. Don't I have f prime of 3? I do. It gave it to me. So it's 1 over 7/2. So it's 1 over 7/2. Can't have a fraction and a fraction. I'm just going to flip the second and multiply, and I'm going to end up with 2/7. And there we go. That is my answer. Not so bad. Now, sometimes you're not given everything, and you need to find it. So, same type of question, find f inverse prime of 2. So really, if I'm going to my what do I need to know, well, this is equal to 1 over f prime of f inverse of 2. So I need to find the inverse of 2. And we can do that. So what we're going to do here is look at this function. So when does this function equal 2? Kind of like what I'm up here. I need to figure out what that is. So when does that equal 2? Well, 2 equals x cubed plus 2x minus 1. And for a lot of these problems, it's just going to be a quick, simple guess and check. You don't actually need to go through and solve the problem and have to factor it or use the rational root theorem to find all the possible roots and then synthetically divide and guess and check and get all that stuff done, because some of these are pretty complicated. All you're going to do is just a quick little guess and check. What number can I plug in to make this equal 2? Oh, well, 1 plus 2 times 1 is 3 minus 1 is 2. Great. So x is 2. So, sorry, not 2, 1. I just said 1 and I wrote 2. So f of 1 is equal to 2. So what does that mean? F inverse of 2 is equal to 1. Now let's take this information, bring it right over here. So this is equal to 1 over f prime of 1. What is f prime of 1? Well, let's go ahead and do that right here. F prime of x is equal to 3x squared plus 2. That's it. So f prime of 1, plugging it in, is going to be 3 times 1 squared plus 2, which is a solid 5. So now this is equal to 1 over 5. And that's it. That is everything you need to know about inverse functions in calculus.